Hi, mathematicians. This is Mrs. Shopper coming with some more vocab, right? Who doesn't want more vocab in math class? So, medians and altitudes, that's what we're talking about today. So, the median of the triangle, what is that? This is brand new. It has one endpoint as the vertex, and the other endpoint is somewhere on the opposite side in the middle. Okay, so it is in the middle. It's not necessarily perpendicular. It's in the middle, okay? And the point of concurrency for the median is called the centroid. So you can add this to the incenter and circumcenter as points of congruency of triangles, okay? So what is the centroid theorem? The centroid theorem says that the medians intersect at a point called the centroid, and it is 2/3 of the distance from each vertex to the midpoint. Okay, so what that means is from the vertex to the point of concurrency, that is 2/3 of the distance from the vertex to the other side. Knowing that relationship, again, study it, practice it, study it, practice it, right? You've got to know that vocab. So let's talk through what this means. In this picture, we know that P is the centroid. All right, so now I'm going to expect you to know centroid is the point of concurrency for medians. I know the medians go from one vertex to the other side. All right, and I know from the vertex to the point of concurrency is 2/3 of the entire length. We expect that you know that. You've got to study it. Here we go. So P is the centroid. That means it's the point of concurrency for the medians. And YV is 12. YV. I got to draw it all the way. YV is 12. Not quite sure why I'm having difficulties here. But, okay, YV, that is 12. Okay, now we have to find YP and PV. So YP is equal to 2/3 of YV. Okay, we know that YV is 12. So YP is equal to 2/3 of 12. The measurement of YP is 8 units. Therefore, the measurement of PV is 4 units. Okay, it is 4 units. Okay, using that connection. All right, let's go through another one. In this equation, R is the centroid. The centroid is the point of concurrency for the medians. It is from one vertex to the other side at the middle. So for example, we know that LQ and QP are congruent because the median bisects the opposite side. We know that NO and OP are congruent. We know that MN and ML are congruent. So R is the centroid, and LO is 30 units. What we want to do is figure out LR and RO. We know that from the vertex to the point of concurrency to the centroid is 2/3 the distance of the entire median. So LR is equal to 2/3 of LO. We know that LR is 2/3 of 30 because LO is 30 units. So therefore, the measurement of LR is 20 units. It's 20 units. Okay, 20 units. And then RO would be the remaining amount, which is 10. Okay, talking about medians, the point of concurrency for the medians is called the centroid. It goes from one vertex to the middle of the opposite side. The distance from the vertex to the centroid is 2/3 the distance of the entire segment. Altitude. Oh my goodness, so much vocabulary. We got to practice, practice, practice. So the altitude is a perpendicular segment from the vertex of the triangle to the opposite side. You've been working with altitudes since elementary. Whenever you had to figure out the height of a triangle, that's the altitude. The altitude is the height of the triangle. It goes from one vertex perpendicular to the opposite side. All right, so we often call that the height. And I know you've been working on it since elementary because my 5th grader is working on it. So here we go. It's the height. Now, the point of concurrency for the altitudes is called the orthocenter. The orthocenter is the point of concurrency for your altitudes. Okay, for your altitudes. Now, there's nothing really special about them. Like there's no like real, it's not like they're all the same measurement or they're all equal distance. That is the orthocenter. What we do know though, is that they're always perpendicular. Okay, so that does help us when we're working with our triangles. So here we go. We have the vertices of ABC. We want to find the coordinates of the orthocenter. All right, here we go, kiddos. We have to solve a system right now. So I need you to get your system thinking hats on. How are we going to do this? Okay, so the orthocenter is the altitude of a triangle. It goes through the vertex and it is perpendicular to the opposite side. All right, so with this one, what we're going to do is, actually, here's what I want you to do. If you need questions on this one, it's going to take a while to explain on the video. I want you to set up a Google Meet with me and ask me. This is going to take me a few minutes to walk through, and I want a dialogue rather than have you listen. So let me know what you need on both of those. Okay, so with that, right here is a chart. You should be able to, without a doubt, fill in this chart if I had it blank. Okay, so let's say that Shopper didn't have any of this stuff in here. I just had the grid and I had the titles. You should be able to, before your next quiz, fill that in if it was blank. That's how much I need you to study and prepare for this, because on your assessment, I'm going to be asking you to tell me something about the angle bisector. And if you don't know what we know about its point of concurrency, that's going to make it challenging. Okay, so with this, I want you to be able to study this. You might just happen to see it. Okay, and again, if you've got questions on finding the orthocenter, please ask. It's one of those that I want to dialogue with rather than just have you here. Okay, so with that, if you have any questions, let me know. Otherwise, until next time, enjoy.